Okay, hi. We're back. So in our last video, we worked our first Doppler equation problem. And now I think the next thing to do is the simplest thing in the world, is just to say, instead of the car moving towards us at 20 meters per second, the car is moving away from us at 20 meters per second. Everything else is the same. I think our original frequency was 256 hertz. If it wasn't, it is now. Okay, and so now, once again, we, the detector, are not moving. So our velocity is 0, so we get to use this simpler equation. Now, you don't have to use these simplified equations. This one would work fine for everything. Everything. The only problem is there's a lot of places to plug things in, so there's a lot of places to make some mistakes. So the simplified one is a little easier, I think, to manipulate. So here we are. The velocity of the source is now negative 20 meters per second. Okay? So before it was positive 20. Now it's moving away from us. All right, so what's the frequency we detect? Frequency of the source, 1 over 1 minus the velocity of the source, which is negative 20 meters per second, divided by 343 meters per second, which is the speed of sound. Okay? And before we go too much further, let me ask you about units. This is this big factor we multiply the frequency by, and what are its units? Well, think about it. Okay, what do you think? Well, we've got, these don't have units at all, and this is meters per second over meters per second. So what does that give me for units? Right, nothing. So this is a unitless factor, and that's good because I want frequency, and I'm multiplying something that's already in the units of frequency. This is basically a good thing. All right, so we're going to do this thing, right? So if I multiply this out on my calculator, 20 divided by 343, I get 0.058. All right, now I'm minus a negative number, right? So that means I'm adding that number. So in the problem before, we were subtracting it. Now we're adding it. Okay, so I add that to 1. I get 1.058, 1.06, but whatever. And then I have 1 over that. So the calculator has a button for that, 1 over x, and that gives me 0.94. Okay? See if it doesn't. And we're multiplying that by 256 hertz times 0.94. You see we've picked up a cat since the last video, so we're trying to work this problem without troubling him. Yeah, that's right. Okay, so I multiply that times 256, and that gives me, well, technically it gives me 241.89, 0.90, whatever. But in real life, we don't have that many sig figs here. Let's be kind to ourselves and say we have 2 sig figs with the 20, and that limits our sig figs to 2. So that means it's 240 hertz. Okay, so what did we expect? Does that make sense to us? The ice cream truck is moving away from us. So is the sound going to be higher pitched or lower pitched? It's going to be lower pitched. And in fact, this is a lower frequency than that. So doesn't look too bad. The cat's still comfortable, so I think we did a good job.